Hello, everyone, and welcome to We Are Learners once again. The topic that we'll be discussing today is polynomials, right? So, we'll be having three different sessions on this. Power revision session number 1 and session number 2 will be released shortly, right? However, power revision session number 3 will take 1 or 2 days, right? So, right after releasing power session 1, right? Power revision session 1 and power revision session 2 by today or by tomorrow, I'll be releasing session number 3 after 1 or 2 days. Fine. Let us jump to our roadmap. This is how our roadmap is structured, right? We'll see mind maps first, right? And then we'll have introduction. We'll be trying to define what do we understand by polynomials, how algebraic expressions are different from polynomials, or how polynomials are different from algebraic expressions, right? Or are they interconnected? Can we say that all algebraic expressions are polynomials, or can we say that all polynomials are algebraic expression? This is something that we'll be considering, right? We'll also be having types. That means based on the degree, that is the classification, and based on number of terms. Then we'll see what do we understand by zero of a polynomial. And at the end, we'll be having remainder theorem into our consideration, right? So power revision session 2 comprises of remainder theorem, long division method, and factor theorem. All right. And algebraic identities will be covered in session number 3. Fine. So let us have a look here. This is how our mind map is looking like. Under polynomials, we'll be studying types of polynomials, zero of a polynomial, or can we also say that zero is nothing but a root of a polynomial? Under what circumstances we can say that zero is nothing but a root? How zero and root, they are the different terms. What do we understand by zero polynomial? So there is a difference between zero of a polynomial and zero polynomial. All right. In factor theorem, remainder theorem, I told you that this is something that we'll be considering, right, in next session as well. Algebraic identity is session number 3. So let us get this started. This is how the definition of polynomial is defined. A polynomial is an expression consisting of variables and coefficients that involves only the operation of addition, subtraction, multiplication, and whole number exponents. You need to remember here that division is not allowed. So I'll be giving you two rules in order to have something as a qualified polynomial. But before than that, we just wanted to have an understanding. What do we understand by algebraic expressions, right? So example is given to you. I'll be explaining you this, not an issue. Let me go to whiteboard. Fine. I hope my whiteboard is visible. All right. So according to the definition, everything is allowed except division, right? So let us consider a case. Suppose if we are given with 5x, which is a term, and they are added with this particular thing is added with another term, which is 2, right? A constant can also be treated as a term, right? So this is nothing but an algebraic expression. This is also an algebraic expression, x over 2. All right. Or I can say that 2 over x is also an algebraic expression, right? However, for a moment, we should not be considering this. Let us consider this 2 over x, right? Because this is something that we'll be considering in defining the rule, right? Now, people, this is an algebraic expression. We can say that this is a term as well, right? In order to have this as an algebraic expression, let us add 1 to it. 1 alone is also treated as a term, right? So now this will be an algebraic expression. So in order to have anything as polynomial, we have two rules. Rule number 1 states that power of variables must be whole number. What do we understand by this? If you consider this example, the power of the variable is 1. So this is a whole number. But here the power of the variable, if you actually, bring this in the numerator side, it will be -1, right? That is nothing but an integer. So this is something that will not be considering in polynomials, although this is an algebraic expression. According to rule number 2, division is not allowed. That is what the definition is also stating, right? So if division is not allowed, that means we can have x plus 1 divided by x plus 2. This is an algebraic expression. However, this is not a polynomial because division is not allowed according to these two rules, right? Rule number 2. It violates rule number 2. That is why we are not considering it. In case if you reconsider this, then if you are bringing x plus 2 in the upper domain, then also rule number 1 gets violated, right? Ultimately, you will be having something in negative, right, with respect to powers, especially in, let us consider a case here. Suppose 1 over x plus 1 is given to you. Now, if you bring this to the numerator side, rule number 1 gets violated, right? So again, rule number 1 and rule number 2, they are connected to each other. So that is why we say that division is not allowed. So that is why this is discarded, right? So in order to have something as a qualified polynomial, these two rules are always to be followed. Now, can we say that all polynomials are algebraic expressions, but not all algebraic expressions are polynomials? Yes, that is the correct one. All right, let us move back to our portion where we left. All right, so p of x is given to you as 2x minus 2. All right, so this is a polynomial because the highest power is 1 here, right, which is a whole number. Power means what? The exponent that we are having over x. All right, generally we define an expression of a polynomial in single variable as f of x equals a subscript n x superscript n, right? So whatever the coefficient that we have, suppose if it is nth coefficient, then that will be the power. Nth minus n minus 1 coefficient, n minus 1 power. Second coefficient, second power. First coefficient, first power, although we are not writing it. Zeroth coefficient, right? Power should be 0. So anything that raised to power 0 is 1. So that is why we are not writing it here. The highest power of a variable is called degree of a polynomial, right? So let us move to our one node. Fine. Let us have a look here. So we were defining what do we understand by degree of a polynomial, right? Let us consider a case. Suppose if somebody is asking us to define degree of this polynomial, denotation of this polynomial is p of x. You can also have q of x. This x represents the variable in which you are expressing a polynomial. Now this is a polynomial because the powers are whole number. All right, division is not there. Any other operator will work. Fine. So this is a qualified polynomial. That is fine. Degree means the highest power of a variable. The highest power of a variable is what? 2. So degree of this polynomial will be 2. All right, this is how we define degree. But people take this very seriously. Suppose if it is given to you as x square plus 5x plus 7 plus x square minus 2x square, if something is given to you in this way, right? So it is always recommended to simplify it first. If you are simplifying it, right, then whatever you get, that will be your p of x, and that is in this way you will be defining the degree. So here degree comes out to be 1. It is not like that key just by seeing the highest power you are marking your answer. You will end up making mistake then. Fine. So this is how the basic definitions are defined. Let us jump to the introductory slide again. Yes, now we'll be seeing types of polynomials. So we'll be having polynomials classification based upon degree and based upon number of terms. So let us move to one node again in order to have this explanation. Let us consider an example, 2x minus 2. Now the highest power here is 1. All right, this is p of x. Highest power is 1. So if the power is 1, we call that particular function or polynomial as linear in nature. So this is a linear polynomial. So based on degree, if the degree comes out to be 1, this is a linear polynomial, right? So what if we have degree as 0? Where do we have degree as 0? Now suppose if you are given with something like this, p of x is given to you as 5. Although this x is representing that this is a polynomial in x, but x is something that is missing from here, right? So we can rewrite this as 5 into 1. Instead of writing this 1, can I write this as x to the power 0? Sir, why you have considered only x? Because I need to have a polynomial in x only. X to the power 0 means anything that raised to power 0 is 1 except 0 to the power 0. This is not defined. Fine. So I can rewrite this 1 as x to the power 0. Now people, if you consider the degree comes out to be 0. All right. So this is nothing but a degree of a constant polynomial when this constant is non-zero. The degree is 0. If the constant polynomial is non-zero, then the degree is 0. Sir, what if we have 0 as the case? Now suppose if we have p of x as 0, you can rewrite this as x to the power 1, 0 into x to the power 2, 0 into x to the power 3, dot 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 0 into x to the power 10 lakhs, dot 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 0 into x to the power 1 crore, right? So here you can see that degree is varying, right? So it can have any possible real value. It is practically not defined. It can have any real value, right? Not defined means it can have any real value. All right. It can go up to infinity. Why is that so? Because the moment you multiply, in fact, 10 crore, right? To 10 crore raised to 10 crore. Then if you multiply it with zero, it will become zero, right? So that is why we say that under constant polynomials, we have two categorization, non-zero and zero categorization, right? For non-zero, the degree comes out to be zero. However, for non-zero, it can have any real value. Fine. So linear and constant, we are done with. Suppose if p of x is given to us like this, x square plus 4x plus 7, right? This is a quadratic function. So we say that this is quadratic in nature. All right. Suppose if p of x is x cube plus x square plus x plus 1. So this is cubic in nature. We say that this is nothing but cubic in nature. All right. So we are almost done with defining the polynomials on the basis of the degree. Now let us define them on the basis of terms. Fine. Suppose if we have one term, this is nothing but a monomial. Allow me a moment. All right. So 5x is a monomial, right? Because it contains only one term. While if we add 2 to it, right? So it will be a binomial. Fine. And if we have 5x plus 2 plus y, then that will be treated as a trinomial. Right? It contains three terms. Now, people, here you need to be more cautious because suppose if something is given to you like this, 2x plus, let us say, y plus 3x, right? You cannot categorize this as a trinomial because you need to have the like terms combined together. All right. If they are solvable, please solve it. Obviously, like terms are something that you can solve, right? So further, it can be rewritten like this, 5x plus y. That means now it is a binomial, right? It will not be classified as trinomial. So this is something that you need to take care of. Fine, people? Let us move to our slides. Fine. Now consider 0 of a polynomial. So this is something that is very important. 5x plus, minus 5 is given to us, right? And we were asked to calculate 0 of that polynomial. Now what do we understand by that? Suppose 5x minus 2 is your p of x and they are asking you to calculate 0 of this polynomial. That means for what particular value of x this becomes 0. RHS becomes 0. So in order to calculate this, step number 1 is put p of x equals 0. So that means 5x minus 2 should be equated to 0. Calculate the value for x, right? So x comes out to be 2 over 5. Fine. From this, you can shift this to the other side. It will become 5x equals 2. And that is nothing but x equals 2 over 5. So this is something that I have written. Now here you can get one value, you can get two value, you can get three value, depending upon linear, quadratic, and cubic nature of a polynomial. All right. So that is the most important point that I wanted to highlight here. Let us jump to, okay. We have one more point to be discussed. That point is actually there in grade 10th. Now let us consider one graph here. Now suppose if this is a random graph given to you, right? This is representing some p of x, all right? And it is drawn in a 2D shape like this. And they're asking you to calculate the number of zeros. So wherever this graph touches x-axis, right? That particular point or points will be the zeros of this particular p of x. So we have 1, 2, 3, and 4 zeros. Fine. Now, why is that so? That is something that we'll be, considering when we'll be discussing next session of polynomials for grade 10th. Fine. Let us jump to our slides back. Remainder theorem. All right. So this is the last topic that we'll be considering under power revision session number 1. The very statement is given to you as when p of x is divided by g of x. The spelling of divided by is something that is, actually a typo. So it's okay. We'll be correcting it. Allow me a moment. Let me correct it. All right, so I've corrected it. I hope now it is up to the optimum. So when p of x is divided by g of x, which is x minus a, right? The remainder is r equals p at a. What do we understand by this? So p of x is given to us as x square minus 5x plus 6 and g of x is x minus 1. Suppose if somebody is asking us to calculate the remainder when this p of x is divided by g of x. All right. Then ultimately, see, whenever we are talking about division, we usually think of long division, right? Let us move to our whiteboard in order to have this. Now, suppose if somebody is asking us to divide, suppose 17 by 2 is something that we are given with. So usually we have 17 by 2 in this way, right? 8 times 16, then the difference is 1. So 1 is going to be the remainder. This is the quotient, this is the divisor, and this is the dividend, right? So we can write that dividend equals divisor into quotient plus remainder, right? This is something that we can have. But what if we are given with something in terms of p of x? So p of x that was given to us was x square minus 5x. This is x square actually, plus 6. G of x was x minus 1. They're asking us what is the remainder when p of x is divided by g of x. So according to remainder theorem, focus on g of x, put this g of x equals to 0, calculate the value of x. So that means x minus 1 should be equated to 0. X comes out to be 1. Whatever the value that you get here, right, for x, substitute that value here. So it will be value at a polynomial, right? Value at particular point in we can calculate for p of x, right? So if you substitute here 1 instead of x, it will be 1 square minus 5 into 1 plus 6. Solve it using board mass. All right, so it will be 1 minus 5 plus 6. So check if you are getting 0. If you are getting 0, then remainder theorem will get changed to something else that we'll be considering in power revision session number 2. So this will be, according to board mass, we need to have addition first. So that means this will be 7 minus 5. So this will be 2. So 2 comes out to be the remainder. If you are solving it using long division method, like the one that we have solved before than this, right? Using numerical examples, we'll be considering this in power revision session number 2. So we'll see that are we getting the same remainder or not, right? This is something that we'll be considering in next session of polynomials, right? So with this, we conclude the session, people. In case if you have something to be discussed, you can definitely give me your status in the comment box, right? And in case if you want any other topic, right, to be prioritized before we have any other session to be considered, you can definitely give me that thing also into comment box. Fine, people. Thank you so much. Acha, if you are new to the channel, please do subscribe the channel. Thank you. Bye-bye.